if y equal to x plus the square root of a squared plus x squared, where a is a constant, prove that a squared plus x squared multiplying d squared y all over the x squared plus x multiplying dy dx minus y equal to 0. Now, this is written in this form to make it easier to differentiate. So let this be equation 1. We now differentiate dy the x equal to differentiating x, we have 1 plus differentiating this using the shortcut method. We bring down the half, multiply by everything in the bracket, a squared plus x squared. Then we subtract 1 from the half, we have negative half times, we now differentiate everything in the bracket, a is constant, we differentiate x squared to have 2x. Meanwhile, this, we cancel this so that we'll have x to multiply this. We now have 1 plus x into a squared plus x squared all to power minus half. Now we're going to take the second order derivative, d square y all over the x squared equal to 1 is a constant, that becomes 0. So we use product rule. We differentiate the first, which is x, 1, dot write down the second, a squared plus x squared all to power minus half, then plus write down the first x dot differentiating the whole of this to bring down the negative half. So we have minus 1 all over 2 multiplying everything in the bracket, a squared plus x squared, then minus half, we subtract 1 times, we now differentiate everything in the bracket, a is constant, then we differentiate x squared to have 2x. 2 here, we cancel 2. Now in that case, we have bracket a squared plus x squared all to power minus half. Then the minus will affect this, minus, we have x times x will be x squared into a squared plus x squared. Now we evaluate this, minus half minus 1, this is over 1, the LCM is 2, 2 into 2, 1 times minus 1, we have minus 1, the minus sign, 1 into 2, 2 times 1 is 2, so we have minus 3 all over 2. In place of this, we write minus 3 all over 2. Now, in that case, this is the second order derivative. From the question, we multiply the second order by this and the first by this, we subtract this. So, a squared plus x squared d square y all over the x squared means we now multiply all this by a squared plus x squared dot this a squared plus x squared all to power minus half. Then we have a minus x squared out. We now multiply the same a squared by this. So we're going to have a squared plus x squared multiplying this a squared plus x squared all to power minus 3 all over 2. Now in that case, since the bases are the same, we add their powers. 1 is here, so 1 minus half, we're going to have a squared plus x squared all to power half, then minus x squared. The same thing, 1 is here, so we're going to evaluate 1 minus 3 all over 2. The SM becomes 2. 1 into 1, 1 time. 1 into 2, 2 times. 2 times 1, we have 2, the minus sign. 2 into 2, 1 time. 1 times 3, we have 3. So we have 2 minus 3 to have minus 1 all over 2. Then, in place of this, we have a squared plus x squared all to power minus half. Now, we are also going to multiply the first order by x, which is this. Now, x dy the x means multiply this, 1 times x becomes x plus, now x to multiply this, we have x squared into a squared plus x squared all to power minus half. Now we're going to add them together and subtract this so that a squared plus x squared d square y all over the x squared plus x dy the x minus y simply means, now in place of this we're going to write all this. We have a squared plus x squared all to power half minus x squared into a squared plus x squared all to power minus half. Then the plus sign plus x multiplying the first order, which is this, x plus x squared into a squared plus x squared all to power minus half, then minus y, and y has been given from the beginning as this. So minus y means minus x, and the minus sign will affect these two. We have minus bracket a squared plus x squared all to power half. Now we are going to simplify them. Of course, know that these, we cancel this, they are the same. The one that has x squared, this we cancel this, and x we cancel x. That means all these equal to 0.